And Willem is going to be telling us about cadmium-free quantum dot color converters for micro LEDs.
So, all right. Thank you all for joining my talk about cadmium-free quantum dot color converters for micro LED applications. My name is Willem Walravens. I'm CTO and co-founder at QustomDot. And at QustomDot, we deliver cadmium-free um, quantum dot color conversion specifically for micro LED applications. Before continuing, let me just disable the camera. Okay. All right, so micro LED applications or displays, they're quite interesting because they combine very high energy efficiency with incredible brightness. And so that in turn unlocks really a lot of cool applications that go way beyond any of what any of the current display technologies can do. You see some cool examples here in the pictures, but today it's not yet a commercially viable technology. And this is mainly because manufacturing costs are still too high today. And because red micro LEDs, they are inefficient, they're expensive to source, and not that easy to integrate. So that's why at QustomDot, we believe that red and green quantum dot color conversion actually enables a commercially viable micro LED technology. And that is because color conversion, it simplifies the manufacturing, so it reduces the cost of manufacturing, and because it can deliver very high performant red and green micro LEDs. I will briefly go into the two of these benefits of color conversion before talking a bit more about the quantum dot challenges. And so looking at the manufacturing side, there's 2 points. First is the mass transfer, where if you're using conventional methods, you will start from a red, green, and blue micro LED wafer or interposer, and then you do a mass transfer color by color, so one by one to your target substrate. This means that you have three separate transfer processes, and the overall process yield, the transfer yield, is product of these three individual processes. Because your yield is such an important metric to become cost effective in manufacturing, this is really where a big part of the issue lies. What you can do with color conversion is, for example, you can start from a blue micro LED wafer, do a single transfer step to your panel, and then add the color conversion to your panel. So you do color conversion on panel, for example, with inkjet printing, after mass transfer, and you end up with a red, green, and blue micro LED pixel on panel. You can also deliver the color conversion on wafer. In that case, you start then from a blue micro LED wafer, you add your color conversions, so red and green, and you create basically an RGB micro LED wafer, after which you can do a single transfer process of your RGB pixel to your target substrate. This is, for example, interesting if you're thinking about integrating your RGB with a micro IC, then you can transfer this single unit directly to your panel. If your application is micro display, you can also do the color conversion on wafer after the mass transfer process. There, for example, here the blue micro LED would then be your blue micro display wafer, where that already has done the mass transfer, and then you add the color conversion on that micro display wafer, which then gets diced and packaged into your micro display. So in that sense, the color conversion really simplifies the manufacturing by reducing the number of transfer cycles that is needed by a factor of 3. So instead of having 3 individual steps, you go to one mass transfer step plus an additional color conversion step. And so this improves your overall transfer yields tremendously. At the same time, you still get some flexibility in where or at which stage you implement the color conversion, depending on which application you're after or which process flow you have. The second point in the manufacturing is more related to the red micro LEDs, because there you're working with a different material, the Allen gap, compared to gallium nitride based. And so these materials for red micro LEDs, they behave very different. They have different optoelectronic properties, meaning that you drive them at different conditions. And so if you want to accommodate for that,